This is a video recording regarding amplitude modulation. Now in communication, modulation means to change, to alter. In communication we have got modulation. In modulation we have got two signals, modulating signal and carrier signal. Modulating signal is also known as baseband signal. In communication there is limitation to transmit a baseband signal to higher distances. So because normally the baseband signal or the information signal which is being generated is of low frequency range, it is difficult to transmit this particular signal to much higher distance. In order to avoid this drawback, we increase the frequency of the signal which is to be transmitted, so that this high frequency signal can be transmitted to a much larger distance using some or any of the modulation techniques which are available in our communication system. Now in modulation, the information signal or the baseband signal or modulating signal is used to modulate one of the properties of the carrier signal. Carrier signal generally is of high frequency range. This carrier signal is having high frequency range, and property of this carrier signal is to be changed according to the modulating signal. Now generally the signal used in communication system is cos wave, cosine signal. Now in case of amplitude modulation, we change or alter amplitude of carrier signal according to modulating signal. This modulating signal is basically the information signal which is received as an output of a transducer to convert a particular information variable into electrical form. Now in modulation, what is required is to change. In case of amplitude modulation, amplitude of this carrier signal is to be changed according to information signal or baseband signal or modulating signal. So we have got basically amplitude, frequency and phase as the three properties of any signal, and any of these three properties can be altered or used or changed according to the modulating signal. When we change amplitude of our carrier signal according to the modulating signal, the modulation is known as amplitude modulation. When we change frequency of carrier signal according to the modulating signal, it is known as frequency modulation. And when we change phase of carrier signal according to modulating signal, then this technique is known as phase modulation. Here in this lecture we are going through amplitude modulation, in which amplitude of carrier signal will be changed according to modulating signal. As can be seen in the slide, amplitude modulation is a process where the amplitude of a carrier signal is altered or changed according to information in a message signal. Next, the frequency of the carrier signal is usually much greater than the highest frequency of the input message signal. When we have changed our carrier signal according to the information or modulating signal, all the information which was present in the modulating signal or baseband signal has been transferred to the carrier signal, and now this carrier signal can be transmitted to a much higher distance in comparison to the modulating signal which was having very less frequency. The carrier signal which we have used is generally of radio frequency range, high frequency, and can be transmitted to a much larger distance. At the receiver side, when a carrier signal is received, it is to be demodulated back to get the information or information signal. So the process at the receiver end is known as demodulation, and in demodulation we try to retrieve back the information which has been encrypted or in our carrier signal. As can be seen in the diagram, the envelope amplitude modulated waveform has been seen, and the envelope is the peak variation of this carrier signal is known as the envelope. Mathematical expression is given in the slide. As can be seen from the mathematical expression, now the equation of an amplitude modulated wave will consist of three components. The first one is the carrier signal, the original carrier signal which was being used to carry out the modulation. The two other signals are upper sideband and lower sideband, as can be seen in the diagram. Upper sideband is the upper portion of the amplitude variation, and the lower sideband is the lower portion of the amplitude variation. As can also be seen or is evident from the diagram, that both upper sideband variation and lower sideband variations are replica of the original modulating signal which has been used to generate this modulation. Now the receiver side will be having this signal, and we can get our modulating signal or information back either from upper sideband, that is upper variation of the amplitude of carrier signal, or from lower sideband. Now this is AM spectrum. If the variation of frequency of amplitude modulated wave is to be seen in frequency domain, then we will be having, as can be seen in this diagram, the first representation is of frequency spectrum of modulating signal, another one is that of carrier signal. As can be seen in the diagram, it has been represented in the form of ST, as can be seen in the diagram. We have got one central frequency in the range as shown in the slide, 4000 Hertz, and we have got two sidebands, one lower sideband and one upper sideband. Lower sideband is at 3500 Hertz and upper sideband is at 4500 Hertz. This is a representation of how exactly this particular thing modulation is being carried out. We have got MT as modulating signal, K is modulator, and this after modulation is shown in a circle diagram as a cross. Then we have given this modulating signal after a little bit of modification and carrier signal to the modulator, and in the output we have got a modulated waveform. Now this modulation technique can be understood using different techniques. This in amplitude modulation, as can also be seen from this diagram, that mathematically in this expression, if we decode this mathematical expression of ST, we will get AC cos omega CT plus MT cos omega CT. This is a mathematical term containing two trigonometrical terms, and if it is expanded, we can get cos omega C plus omega M, and one term having cos omega C minus omega M. Then a term having cos omega C is carrier signal. The term having frequency range, the term in the center with cos omega C is a carrier signal. One term with cos omega C plus omega M will be upper sideband with higher frequency omega C plus omega M, as was seen in the spectral diagram. The term with omega C minus omega M will be lower sideband with a lower frequency range, as can be seen in this diagram. Now this amplitude modulation signal can be transmitted, as the carrier is having a larger frequency. It can be transmitted to a larger distance, and at the receiver side the information, this amplitude modulated signal will be demodulated to get the information or baseband signal back, and then the information could be retrieved. We have got different circuits to implement this amplitude modulation techniques, and in next video lecture we will be going through circuits with the help of which we will be implementing this amplitude modulation technique. Now this, as can be seen from AM spectrum, this modulation technique, as is in lower frequency range, is prone to noise disturbances, and these noise spikes will be present in the form of, in the spectral, in the form of different noise signals. This is demodulation, one of the demodulation techniques which will be used at the receiver side: square law demodulation, coherent demodulation, and all these things can be simulated using software tools which are available like MATLAB. The slides we are going through have been designed using MATLAB, and all these simulation regarding modulator, demodulation, spectrum waveform, frequency spectrum waveform, and carrier signal representatives can be easily seen using this MATLAB software. There are various simulation environment could be created using this MATLAB, and on these environments, these diagram or variations could be seen. Thank you.